Uh, yeah, so hello guys. Today is 25th May 2024, and today we are going to solve our next problem of the day. Right, so as we all know, that we are pretending it to be a Google mock interview. Right, we are trying to copy that format, and we are like approaching the problem in the similar way. So let's just dive it into today's problem. You are given an array string words uh, like before. What we do is we mention all the given items, so it makes us clear when we are writing the pseudocode what all items are given, right? It makes us easier to recall and keep the track of everything that we are going through, right? So we are given an array of strings, right? Again, this is called as words. Make sense? And each element of words consists only of two letters, which is consisting of two letters, and those are lowercase letters, right? These are small details that we have to keep in mind because this can drastically change our coding approach, right? If those were let's say uppercase characters, right, then suppose we are maintaining a vector of 26, then to calculate the frequency, right, for lowest case character we can just do str of I minus a, right? So it will point to its respective position from index 0 to 25. What if it's a uppercase character, right? Then this 20 till 26 won't work. Then we have to make a larger array according to their ASCII values, right? So these are small details that we have to keep in mind as we are going into the problem, because these small details will eventually help us frame a complete answer, right? So what we have to do is we noted down all the given things, right? An array of strings, and that is consisting of two letters words. So we have to create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Okay, so we can select any amount of words as long as they form an palindrome. We can put them in any order in the final string. Each element can be selected at most one, makes sense. Return the length of the longest palindrome that you can create. If it is impossible to create any palindrome, return 0. Alright. Palindrome is a string. We all know what a palindrome is, right? Alright. So the ask of the question is, we have to find the longest palindromic string we can form using these words in any order, right? Simple as it is. So now the third process that I do is create a thought process column. All right, so let's see what we can do in this problem. We know that the word are consisting of only two letters, right? So we know that if LC is present as a word, then if we can find CL, right, we can use them, right? And let's say it is present three times, and it is present five times. Then what is the maximum number of time we can use them in our final string? I would say three times, right? Because we can do like LC, and then CL, because we can't use LC five times or CL five times, because if we use CL five times, then the remaining two times would not have any counter, right? Counter LC to back it up. Hope this makes sense. So we can come to a conclusion that minimum of frequency of str, right, comma frequency of its reverse part. Let's give it a name as reverse str. So we have to take the minimum of these two frequencies, right? And these are for when the words when the letters in the words are different, right? if the words, now the second case comes, this is case 1, right? Case 1. Case 2 है when the words are similar, right? Like GG, AA, B, BB, CC, right? All these kind of words. These have some strange peculiarity about them, and that is they both have similar letters, so they can make an exception. How did I come to this conclusion? Because let's say we have AA 5 times. What if I say I can include all the odd number of times, right, in the final string? AA, right? This is a palindromic string, right? So for the similar letter words, I would say that I can take even and odd both the frequencies and end up with a palindrome, right? But what if there is a combination of both the cases, right? Let's say LC and CL is present and AA. Can I do this? I can do this, right? But what if I say I have another character BB? What now? Right? Let's say BB is present 2 times, or let's say 3 times. Now, can I still form a palindrome? How can I form the longest palindrome in this case? Let's figure it out, right? Let's say LC came here and similarly CL came at the last. Now AA came here to back it up. Now BB came here, BB came here to back it up. Now what we are left is one AA and one BB, right? Because there are 3 BBs and 3 AAs. So the question is, doesn't matter, right? If I put AA or BB here, I cannot form any string longer than this, right? So what did we notice here? That if the characters are similar, then we can take at most one extra frequency of that word and put it in the between, right? Just like normal palindrome occurs with single string, right? Let's say A B C and C B A, and let's say I can put it E here in a single character palindromes, right? So since I know how single character palindromes work, I always knew that there is one strange thing that can happen in between, in exactly mid, like we can put E and still end up with a palindrome. And how can I map this similar behavior with the 2 letters? That is, we can take a similar letter words and we can use at most one. Doesn't matter which frequency or which character we are using, A or BB, right? So we can still form this longest palindrome. I hope my thought process is clear till now, and yeah, this is, I think, the very much that we can think about this in this problem. Let us try running some test cases now. Important part. Since I have came up with an approach in my mind through my thought process, now what will I do is I'll try to put that approach into this sample inputs and see that if I end up with the correct answer or not, right? So CL, LC, GG, I know that these are different characters, so I will take the minimum frequency of both of them, that is 1, right? LC, CL, right? And for the similar characters, right, I can take this GG. So for similar characters, right, for similar characters, if frequency is odd, then we can take even number of times, right? We can take them even number of times and say one extra odd can still be taken. I hope I am making sense here. How can I back it up, this example, from this thing, right? Where we are given LC, CA and both AA. This is the example, right? Here LC is present, let me make it more clear. Here LC is present 1 time, CL is present 1 time, A is present 3 times, right? And BB is also present 3 times. So if those are having different characters, right? So these are having different character, है ना? These are also having different characters. These are having same characters, and these are having same characters. So I am having different cases for similar and different characters. So if they are different, what I do is I take the minimum of both the frequencies, right? Both the frequency of the word, and put them in the answer. For similar, what I do is if they are occurring even number of times, I will take them all. But if they are present odd number of times, then I can take this AA 2 times. Also I can take this BB 2 times, right? But what I can extra thing I can do is I can say that there is still room for one more AA, BB, or any other word, any others word in this similar case. What is this case? Having similar characters. Makes sense? Yeah, so this is the complete approach. This is the complete thought process that would I need to solve this problem. Right. So how did I come up to this solution? I categorize the problem into two cases. Obviously, those two cases are visible to us, having different characters or having similar characters. So I figured out what can be the answer for the different one. Like we can just take the minimum of both the frequencies of the word, right? What are those two words? Simple word and its reversed word, right? And for AA and BB similar characters, since both this reverse part and original part would be same, right? So this has to be tackled in some different approach. And what is that approach, right? We can take the even number of times, and we can say that there is still room present for one more, because like I showed before, for single character palindromes, in the mid part we can put any character, right? It doesn't have to have its counterpart. By counterpart I mean that it doesn't have to present its reverse part, right? We can put that in between. Similarly, for similar characters I can have an extra part, right? We can take AA and BB 2 times, and I can say that there is still room present for one more AA, BB, or any such character having similar characters, any such word having similar characters, right? So how about we write the pseudocode now, since I can tell my interviewer that I am done with my thought process, and I have dry run my thought process in the sample inputs, and I see the correct answer coming. I think this is enough to proceed with the pseudocode. He would say, yeah, sure, you can. So let's dive into it. Let us create a method called as what is this? Return longest palindrome. Right. Like I have talked this in my earlier video, what parameters should be given and how do we map them? By looking it into the given phrase, what we are given. We are just given an array of words, right? So let's just vector of string call words. That's it. Why I write all those things? Because it helps me develop a clear mind map, right? Since I know just one thing is given, so I don't have to like keep worrying about other things, right? Just take one parameter word string and I can proceed with the solution. So first of all, I would need the frequency of words, right? So I can just traverse the words array and have a map, let's say unordered map, since it doesn't need the ordering, right? Let's say frequency. So what I can do is frequency of EL plus plus. So this way I know the frequency of every other word. Now I can just simply traverse in the word, right? Simple as that. Let us also create a variable called as answer and extra odd. Why we are making this extra odd? Just like I have told in approach, this extra odd can be put it in the between of our final palindrome string, right? Just like in the single character palindromes happen, we can put any character irrespective of finding its counterpart. So this is for that part only, that counterpart, those word which doesn't have to have their counterpart. So this extra odd represent that thing. I hope it makes sense. So now what we can do is we can say string current word. Current word is words of I, right? And string its reverse part. Reverse word is, we can just give it current word, and we can use the reverse method. Since it's having only 2 letter, so I don't think this would even impact the time complexity, right? So this is the C++ method to reverse the string. There are several other ways which I would use here, but I think this is fine. So we have two words, current word and reverse word, right? uh, we can just mark them as seen. Also I will create another map so that I don't keep repeating my answer again and again, right? If I am done with these words, like, I can just mark them as seen. Seen as reverse word plus plus. So also once if I have seen them, right, uh, or seen of reverse word, then I don't have to worry about finding their answers anymore. I can just continue, right? Now if they are unseen, now here's the algorithm begins, right? Algorithm begins here. Now what were the algorithm that we discussed? We have to case them, right, into case 1 and case 2. What is case 1? When if my current word is equals to my reverse word, right, having similar characters, of course they would have similar counterparts, right? Then if the frequency of my any word, since both are similar, current word is modulo 2, right, then I can say this extra odd is present, that I can put it in between. Doesn't matter which word it has to come from, right? Because we are only worried about the final length. So we can say that I have this extra odd that I can put in between irrespective of finding its counterpart. And I can take what I can take is the even number of frequency, right? Frequency of current word, right? Current word -1, of course, right? Since it's odd, -1 would give me the even part. And answer, what will be the summation that I have to do in answer, right? Since I know this is 2-character string, right, if I take, I can say this is the answer. Makes sense, right? Because take is the amount of words that we are taking, and since each word is of length 2, I can just say 2 star take. Makes sense? This is for even, this is for odd, and if it is even, then I can say I can just take them all, right? Answer plus is equals to 2 star frequency of current word. I can just take them all, right? I don't have to take even because they are already even. And the other case is, okay, I'm done with this if else, right? Yes, this if else is done. Now the other if else is if they have different cases, if they have different letters. This is the other case. So if they have different letters, then what is the answer? Simple. We can just take the minimum of both the word, current word, and the frequency of reverse word, right? Because these are different, and there has to be this must condition that its counterpart had to be present. If its counterpart have to be present, then we have to take minimum of both the parts, right? And what will it contribute to the answers? Let us see. Let us just take an example. LC, LC, CL, CL. What will be the take value in here? Of course 2, right? Because LC is coming 2 times, CL is coming 2 times, so take is 2. But what is the actual answer? What is the length that we are contributing? It is 8, right? And how it came? Because I had said 2 star is the length of single character, and 2 star is for countering part, right? LC is been taken 2 times, but we have CL also present 2 times, right? That is why this extra into 2 is coming. Take, This is making sense, right? This has to make sense. LC is coming two times, right? And CL is also coming two times, but we are not considering them in take, right? We are just finding the minimum, so we'll have to do 2 star for the counterpart as well, right? And take is the amount of times we are taking LC. This is making sense, right? The first two is coming since we have two character length, and the second two is coming for the count of its counterparts, right? I think that should be it. The final answer would be answer plus extra odd. I told you, right? If extra odd is present, then one more two character word we can add in between, like here. If it is AABB, we can add any AABB in the final answer, right? This is the example. This is the example that we are talking about. I hope this makes sense. My actual interview would be done by now.